So here we are given vector spaces V and W, and T a linear transformation between these two vector spaces. And say we have a subspace W of V, then what we want to prove is that the direct image of U under T would be a subspace of W, or actually, what TU is, that it consists of W such that if we take any W in TU, then we can find V, or let's say X in U, okay, with, or rather what we will have is that Tx would be W, or in plain English, what Tu is, that Tu is the set of images of all the elements of U under T. Okay, so I think I took longer to explain what Tu is than to prove the statement. So let's go ahead, and I made a picture here for you. All right, so here is U and here is Tu. Now remember, in order to show that Tu is a subspace of W, what we have to show is that the zero element in W is in Tu, and that should work, because you can see we have, if we take 0 in U, then T0, okay, that is the 0 in W is in Tu, right, by the definition. Okay, now what we have to show is that if we take two elements, say, so let's take elements, say W1 and W2 in Tu, then what will happen is that we will have X1 and X2 in U, such that we have Tx1 equals W1 and Tx2 equals who? W2. Okay, all right. Now, so X1 and X2 are in U, and U is a subspace. So what we will have then is that X1 plus X2 would be in U, and what we want to show is that W1 plus W2 will be in Tu. So anyways, so notice this, if X1 plus X2 is in U, then their image under T, T being a linear transformation, so we have Tx1 plus Tx2 here, and who these are? These are simply W1 plus W2, all right, and that is going to belong to what? Belong in Tu. So W1 and W2 in Tu means, or it implies that W1 plus W2 is in Tu, right? Now all we have to do now is we are taking our vector spaces over real numbers. So let's see, if we take an element W and a real number, say C, then we would like to see that whether CW is in Tu or not. So if W is in Tu, then again we have an X in U such that what? Such that Tx is W, and remember we have also taken C, a number in the underlying field of real numbers. So we would like to see if CW, which can be obtained by what? If we take CX, then notice this, if X is in U, then U being a subspace means CX is in U as well, right? Okay, so, and what this would be, because T is a linear transformation, this would be CTX, meaning CW, and then it does what? It just goes or just belongs in TU. So what we have is, we have the zero element in TU. If W1 and W2 are in TU, then W1 plus W2 is also in TU. And if we have a number C, an element of W, then C times W is in TU. And these are the three conditions that we have to verify to show that TU is a subspace of W. All right. And I shall post a write-up of this for you. Okay.